Welcome to my YouTube channel. Today I want to show you how you can calculate the maximum design load on the beam. So to calculate that, you need to calculate the total load on the beam. That is the load that is coming from the slab, load the circuit of the beam. You need to calculate the weight of masonry wall, which is acting on the beam, and also you need to calculate the dead load on the that there you can find the total load on the beam. Then you need to calculate the characteristic import load on the beam. So this is especially important if you are going to design your beam manually in design spreadsheets, as I have shown in my previous videos. So let's begin. So let's say we have this beam here, and this beam is currently a wall, and the story height is 2.8. So our story height is 2.85. So let's determine the total load that will be coming to this beam. That is beam. This beam for 50 by 200. So let's start. So we're going to need to know the total load from this slab and this slab, which will basically be equal to the self weight of the slab, which usually equals to, let's say we have a slab of 150, so it will be equals to 0.15 multiplied by the density of concrete, that is 24 kilonewtons per meter cubic. Again, this is the self weight of slab. So this will be equal to 3.6 kilonewtons per meter squared. So the total load that will be acting on this beam here will be equals to the length of the slab spanning on this slab. So that will be 5.6 minus 0.2, because this is grid to grid. Now we want just the slab, that is 5.4. That will be now 5.4 multiplied by this self weight of slab. So it will be 5.4 multiplied by self weight of slab, that is 3.6. So the total load from the slab that is acting on this beam will be equals to, if we do the calculation, it will be equals to 3.6 multiplied by 5.4. That will be approximately 19.44. And that is only load coming from one slab. So there are two slabs on both sides, because this is a T beam, it's not an L beam. So the total load will be now this one times 2. So this will be equals to 19.44 times 2. That is 38.88. That is kilonewtons per meter. So now, so that's how I found this dead load. So it is the total length of the slab times the total thickness times the self weight, which is equal to thickness times the 9.44. Now that is the dead load from, this one is the dead load from a thick slab. So this is dead load from 150 millimeter deep slab. That will be equals to 38.88 kilonewton per meter. Now we want to find the self weight of the beam. self weight of the beam. Now this one is times 2 because it's a T-beam, so there are slab on both sides of the beam. Self weight of the beam will be equals to, so when we have this like this properly, it equals to the depth of the beam, that is 0.45, minus the depth of the slab, that is 0.15, then multiplied by unit weight of concrete, that is 24, multiplied by the breadth of the beam, that is 0.2. Now this will equal self weight of beam will be equals to a total of, that is 24 times 0.2 times 0.3, that is 1.4 kilonewtons per meters. Right, that is 1.44. So let me just find this properly. 1.44 kilonewtons per meter. Okay, so now we need to calculate the weight due to masonry wall. Unit weight, distributed weight of masonry wall, distributed weight. It will be equals to the height of the wall, that is 2.85 minus the depth of the beam on top, that is 2.45, that is will be remaining 2.4, multiplied by the unit weight of masonry wall, that is 20 kilonewton per meter cube, multiplied by the depth. You can get approximately is it 9.6 and 20, 2.5 is 20, and you get 9.6 kilonewton per meter. So now let's do the total characteristic. Now this one is characteristic dead weight on the beam. Will be equals to summation. We take out that will be equals to 38.88 plus 1.44 plus 9.6. That will be equals to 49.92 kilonewtons per meter. So now, what about the live load? So let's say there is a load from slabs on both sides of 2 kilonewton, and it is acting on a length of, so that is 5.4. So that we give the self weight times 5.4. Now this time will be that live load from the slab times 5.4, that will be equals to 10.8. Now coming from both sides, that will be equals to 21. That will be equals to 21.6 kilonewtons per meter. So this is it in post. So now, what about now the design load? Now the design load. Now this is n not h should be equals to now uh, 1.4 dead load plus 1.6 line load, that is 1.4 times 49.92 plus 1.6 times 21.6, that will be equals to that will be equals to 104.448 kilonewtons per meters. So wherever difference, that is how we find. Now this is maximum design load. That's how we find it here. Thanks guys. You know. So that is how I find it.